Hi everyone, myself Anirban, welcoming all of you to beta classes. So our today's target is to learn about uniform motion. So the first question is, what is the meaning of uniform? Uniform means the quantity which doesn't change while the time is changing. Okay, suppose a physical quantity, that is velocity, it is made of magnitude and direction, as it is a vector quantity. So velocity has magnitude and direction. Velocity has magnitude and direction. Okay, as velocity is a vector quantity, it has both magnitude and direction. If this magnitude and this direction, both of these two quantities are constants, then we can say that this velocity is a uniform. Okay, velocity is uniform. So here I have written the notes for you. You can read it, that if velocity of a particle is constant, velocity of a particle is constant, then it is called uniform motion. Okay, velocity of a particle is constant means the magnitude and direction, both of these two quantities are constant, then velocity will be constant and you will say that it is a uniform motion. Okay, then number 2 is velocity is a vector quantity, we know it very well. Number 3, so velocity has both magnitude and direction, I have said it already. Next, so the meaning of uniform velocity means both the magnitude and direction are constants. Okay, magnitude and direction, both of these two quantities are constant, then we will be able to say that this is a uniform motion. Next, since we are learning about 1D motion, so direction is constant. That means you can assume that here is a vehicle. Suppose this is a vehicle which is going towards this direction, and this is suppose a x-axis. It is not changing its direction, it is going straight. So we can say that it is not changing its direction, so it is a 1D motion. Okay, this is a 1D motion, it is not changing its direction. Okay, so in case of 1D motion, we can say that direction is constant. Okay, this is subtle. We can say that direction is constant as we are learning about 1D motion. And the challenging part is your magnitude. If we make constant this magnitude part, then we can say that the velocity is uniform. Okay, understood? Direction is constant because we are learning about 1D motion. And in case of uniform motion, if we are able to fix this magnitude part as a constant, then we can say that velocity is uniform. Then speed or velocity, we know it very well, that speed or velocity, that is equal to distance or displacement divided by time. Okay, so here I am representing velocity or speed as v, that is equal to s by t. Here s is your distance or displacement and t is your time. So v is equal to s by t, so s is equal to vt. Remember this formula, it will help to solve the numericals. Next, in case of uniform motion, we are learning about uniform motion, and in this case, average speed, average velocity, instantaneous speed and instantaneous velocity, all are same. So in case of uniform motion, remember that average speed, average velocity, instantaneous speed and instantaneous velocity, all of these quantities are same. Okay, as we are learning about uniform motion. Here is a question. Question says, a particle is moving along negative x direction with uniform velocity of 4 meters per second. At time t is equal to 0, particle is at x equal to 6 meter find x coordinate of the particle at t is equal to 2 seconds. Very simple question. If you draw this diagram, suppose this is the x axis, okay, and this is 0. At t is equal to 0, particle is at x equal to 6 meters. Suppose this is your 6 meter position distance from this origin, and find the x coordinate of the particle at t equal to 2 seconds. So it is your uniform motion. Okay, this is your uniform motion, as here it is also informed uniform velocity. So here is no acceleration, velocity is constant. So the velocity is 4 meter per second and time is 2 seconds. So we know the relation velocity is equal to distance by time. So velocity is your 4 meter per second, that is equal to distance s divided by time. Time is your 2 seconds. So cross multiply it and you will get the s equal to 8 meter. So when time is 2 seconds, the particle will move x 8 meter. The particle will move 8 meter from this position to that position. So it is your 6 meter and the particle is going 8 meter. So 8 minus 6, that is 2 meter. This part, this is your 2 meter. This is 6 and this is 2. So the total is 8. The total is 8 meter. So the particle is moving 8 meter. That means at first 6 meter, then 2 meter. So the total is 8 meter. So the question is find x coordinate of the particle. So the x coordinate will be minus 2 meter. So you can also write it as minus 2, 0. Minus 2, 0, that means in the y direction it is 0, and as it is in negative x axis, so it is minus 2. Okay, so minus 2, 0. So this is the answer. Here is another problem. Such type of problems are frequently asked in exams. Question says a particle travels half of the total distance. That means this is the total distance, and this half distance I am considering it as s, and this is s, the remaining half part. So a particle travels half of the distance, total distance, with constant velocity v1, and rest half distance with constant velocity v2. Okay, find average velocity or average speed during the complete journey. Complete journey means from this point to that point. So this is the total distance, that is 2s. This is the s part and this is the another s part. So the particle is moving with a v1 speed through this s part and this s part with v2 velocity. So you can assume it that v1 meter per second. Okay, v2 meter per second. It may be meter per second, kilometer per hour. Okay, I am assuming it that it is meter per second. So this particle is moving from point A to point B with v1 meter per second. So I can write it as, or at first we know that average speed, that is equal to total distance upon total time. Okay, we know it, average speed is equal to total distance by total time. So at first we will put the total distance value, that is 2s, s plus s 2s, divided by, the challenging part is here how to calculate this total time. Okay, so the particle is moving from point A to point B, this s distance with v1 meter per second velocity. So v1 meter, the particle goes v1 meter in 1 second. I can write it because the velocity is v1 meter per second, so I can write it as the particle is moving v1 meter in 1 second. So 1 meter in 1 by v1 second, okay, and the particle is moving this s meter distance in s by v1 second. So this s by v1, this is the time required to reach the particle from this point A to point B. Okay, the particle needs to reach this point B from point A with a velocity of v1 meter per second. The time will be s by v1. And similarly, you can calculate that the particle is going from point B to point C. Okay, so the particle is moving with v2 meter per second in this case. So v2 meter, the particle goes v2 meter in 1 second. So 1 meter in 1 by v2 second, and s meter s by v2 second. So this is the second time. So this is s by v1 second, and this is your s by v2 second. And if we add these two times, then we can get the total time. So it will be s by v1 plus s by v2. So it will be v1 v2, v1 cancel, so you can take common this s part, and it will be like this. I have taken this s as common, so it will be 1 by v1 plus 1 by v2. That means I am adding this s by v1 and s by v2. Okay, so v1 cancel, so v2 plus v2 cancel, v1. So it will be s v1 plus v2 divided by v1 v2. Okay, so put this total time in this place. So it will be s v1 plus v2 by v1 v2. So s cancel, so it will be 2 by 1 into v1 v2 by v1 plus v2. So it will be 2 v1 v2 divided by v1 plus v2. 2 v1 v2 divided by v1 plus v2. So this is this one. Find average velocity or average speed. So average velocity is here, this quantity, which is 2 v1 v2 by v1 plus v2, and don't forget to mention the unit, which is meter per second. So the answer is 2 v1 v2 by v1 plus v2 meter per second. Okay, this is the answer.